Every so often, a misconception becomes so widespread that it's worth revisiting. This is one of them. Here we go again.
Charges separate by only the Debye length.
There's nothing wrong with that statement. In fact, it's the standard definition of the Debye length you'll find in virtually every plasma physics textbook. The problem comes in the very next step. An electrostatic concept is suddenly being used to dismiss an argument about electrodynamics. Those are different branches of physics. Keating continues.
In interstellar space, the Debye length is about 10 meters. You cannot maintain the massive charge separations the electric universe theory requires across light years, even light seconds. Even in this dense laboratory plasma, which is highly processed, I can barely maintain charge separation across a few centimeters. But the EU folks, well, they need this to be maintained across galactic distances. It's physically impossible.
But that conclusion simply doesn't follow. The Debye length tells us how rapidly electrostatic charge imbalances are screened in a plasma. It does not tell us how far electric currents, magnetic fields, or electromagnetic energy can extend. Those are governed by electrodynamics, not electrostatics. Even if every electric universe hypothesis were disproved tomorrow, the distinction between electrostatics and electrodynamics would remain exactly the same. Electric universe models do not propose galaxies separated by enormous static charge imbalances. They generally describe quasi-neutral plasmas carrying electric currents. Those are different physical situations. Here's a simple analogy. Imagine a capacitor. Between its plates exists an electric field created by separated charges. That field exists only because the charges are separated. Now imagine a copper wire. The wire remains electrically neutral overall, yet it can carry an electric current for hundreds, thousands, or even millions of kilometers if you make it long enough. Electrical neutrality does not imply electrical inactivity. It simply means positive and negative charges remain almost perfectly balanced, while charge and energy continue to flow. Exactly the same principle applies to plasma. On scales larger than a Debye length, plasma is quasi-neutral. Quasi-neutral, however, does not mean electrically inactive. If the Debye length really limited electrical phenomena to microscopic distances, much of modern plasma and space physics simply could not exist. Yet every standard plasma physics textbook discusses electric currents, magnetic fields, plasma waves and filamentary structures extending over distances many orders of magnitude larger than a Debye length. A quasi-neutral plasma can carry enormous electric currents. Those currents generate magnetic fields. They organize plasma into filamentary structures. They form double layers. They support plasma waves. They transport energy across astronomical distances. None of this is inconsistent with the Debye length. In fact, these are all standard topics in plasma physics. They're discussed in textbooks by Francis Chen, David Gurnett, Donald Nicholson, and Anthony Peratt. Later in the video, Professor Keating appeals to Maxwell's equations, suggesting that critics simply haven't solved them. But Maxwell's equations are not the exclusive property of any one cosmological model. They describe how electric and magnetic fields behave, how currents generate magnetic fields, and how changing electric and magnetic fields propagate as electromagnetic waves. They are the mathematical foundation of electrodynamics. The question is not whether Maxwell's equations apply. Everyone agrees they do. The question is whether their implications at cosmic scales have been fully explored. The Debye length is one of the most important concepts in plasma physics. But using an electrostatic screening length to dismiss large-scale electrodynamics is simply applying the right concept in the wrong context. Now Professor Keating ends his video by saying this.
Don't let people rob you of real cosmic wonder.
Don't let people rob you of real cosmic wonder. I couldn't agree more, but real wonder begins with understanding the physics correctly. Physics doesn't care about YouTube subscribers. It doesn't care about professors. It doesn't care about me or you. It cares about definitions. And it cares about applying those definitions in the correct physical context.